yet, so I was gonna give y'all a quick tour of all my textbooks. So yeah, let's just get to it. So I'll just start with the ones that's on my desk right now. So this first one I have right here. This is Ordinary Differential Equations by with applications by I think it pronounces this Rice, however you say it. Rice, Caligari, and Aluwalia. I've only read the first few pages of this one, but this is the one I'm working through right now. It's pretty solid and clear in terms of explanations and stuff. So yeah, I really like it. It's only ODEs, no PDEs, just ODEs, and it's like for right after you finish calculus type thing going on here. All right. So right here, this is Fundamentals of Engineering Thermodynamics by what's his name? Shapiro and Morin. Really good book. Really clear. It has I actually read through part of this for my first introductory thermodynamics class. It's nice. It goes through a lot of things, like a lot of different topics and stuff. Engineering thermodynamics, so it's different from like a physics perspective, but it also has like a nice number of tables and stuff in both SI and English engineering units. So it's just really nice. It's really nice to me. This next one, let me get these both of these two. So yeah, this right here, these two. Let me see if I can get the light on. This is Algebra and Elementary textbook by G. Crystal. Super old, but really, really good. It goes through elementary, which is just pre-modern algebra, like rigorously. So part two is where the juicy stuff is. It goes over infinite series and the convergence of infinite series and infinite products in chapter 26. And it's just really a lot of good stuff that I need to go through to get my algebra together. So yeah, it's volumes 1 and 2. What else do I have up here? I have Fundamental Laws of Mechanics, the international version by Irodov, which is just kind of an intermediate mechanics book. It's decent. I've gone through the first pages of it. It also treats elementary relativistic mechanics in this book, so I need to go through that. This is Vector and Tensor Analysis by Harry Lass. I've heard good things about this book. I haven't read it yet, but it goes over vector algebra, some differential geometry, mechanics, hydrodynamics, things that involve tensors and stuff and vectors. This right here, this is Vector and Tensor Analysis by Nathaniel Coburn. Borrowed this from my school library, and I went through the first few pages of it. I plan on reading all of these, but it was a bit above my level when I first got it, but I still plan on going through it. This right here, this is Electric Circuit Analysis by Tabor Tsigalis. It's a pretty rudimentary book on electric circuit analysis. It doesn't go through a lot of the mathematical methods. It's good for a first book or a first course. Right. Have some other stuff on here. Yeah, it's kind of junky. This is General Chemistry by Raymond Chang. It's a basic book on general chemistry. Good for a first course. Well, actually, it should take you through your first 2 courses. It should take you through all the general chemistry, just at the basic level. It's nice. I've been working through the first couple pages of this for my break so far. This right here is Fundamentals of Applied Electromagnetics by Fawaz T. Ulaby. This is a good book. I haven't actually worked through any of it yet, but I've heard really good things about it, and it approaches things from like a engineering type of standpoint. It starts with transmission lines and it starts with the applications to engineering first, and then they get into the physical principles kind of. All right. So this is Hyperbolic Functions by Sherbatov. I haven't actually read this book yet, but I never actually learned hyperbolic functions in school. They never taught me it, so I want to go through this at some point. It's a really good book from what I've heard. I'll just leave it at that. All right, this right here is Fundamentals. Well, not Fundamentals. Applied Thermodynamics by Fairs. It's mostly an engineering type of book. Like, this is really like just straight up applications. It doesn't go through like first principles. Like there aren't even like partial derivative relations. With regard to classical thermodynamics talked about here. It's just straight up just applications and stuff, and like building different things. They have a lot of nice diagrams. One thing that I kind of don't like is that it's only in English engineering units, so they only it's only in BTU and just English engineering units. So that's just one thing, but it's actually pretty old, and it's kind of like you can see just how how our terminology has changed over time, and but with that there's a problem book that's actually released with this book. That was released with this book, and it has like 1,500 different problems, and like it's crazy, like just the number of problems, and just like they vary in difficulty, but it's really really nice. So there's a bunch of tabulated data in here too. These are steam tables right here. This is superheated steam. So these are all in English engineering units. Like right here, this is in Fahrenheit. The temperatures in Fahrenheit, all in English engineering units. And you also have like Maillard charts in the back. A Maillard is the entropy versus enthalpy chart. So this one right here, and it's just really classic. Like it's just I don't know. I just like books like these. So yeah, that's that. There's a lot of like engineering applications type things up in here. I have right here. This is Thermodynamics by Obert, and this is a nice book. Like this is actually a pretty old book. People used this back in the day, and I haven't really looked much through this book, but it includes a lot of them. It's a complete treatment of thermodynamics. It's a complete treatment. They go through pretty much everything classical. Right. This right here, this is a famous book, Principles of Mathematical Analysis by Walter Rudin. I think anybody that's watching this video already knows about this book. I haven't cracked it open yet. I'm not ready for it yet. But this PMA, just the the international edition. This right here, this is the Mathematical Theory of Wave Motion by G.R. Baldock and Bridgman. So I got this from my school library, and I tried to get through the first part, but I just wasn't ready for it at first because I haven't had differential equations, and like you're just not gonna be able to. You just need to have more mathematical background before you can get into this, to be honest, than what I had. They have some complex numbers and stuff. I just felt like I should go through DiffyQ first before I tried to jump into some of this stuff. So yeah. Right here, this is Electromagnetism for Engineers by P. Hammond. I've gone through part of this book, and it has good problems and like answers to every single problem in the book. The one thing that I kind of felt was weird was that it doesn't have any like vector treatment. So like there is no use of unit vector notation anywhere in the book. it's straight up magnitudes and stuff. So that's the only thing. That's the one. I wouldn't even call it a complaint. That's just the one thing I noticed about it. Right here, this is Elements of Statistical Thermodynamics by L.K. Nash. It's very good for a first book because the notation is pretty soft, I would say. Like there are no like Boltzmann relations. They kind of skip those. Like everything is like used with like elementary calculus notation. Like these are just ordinary derivatives. Like there are no partial derivative notations in here. All right, so right here, this is General Chemistry by Linus Pauling. Y'all know who Linus Pauling is, one of the founding fathers of quantum. So, you know, it's actually much different from what normal general chemistry like books would be, you know, would teach and would be written like. So it's in a league of its own, to be honest, and it's actually pretty nice. This right here, this big book, this is Chemical Structure and Reactivity by Keeler and Wathers. It's actually really nice, and it has a bunch of nice pictures and stuff. Like this is what I think all general chemistry books should be taught out of. Like this book is really nice. It goes over chemical thermodynamics, all types of bonds, functional groups, and like all types of different stuff. Like here's some of the pictures and stuff. It goes through elementary quantum mechanics. Just a lot of like this is a very complete book right here that I need to read. All right. Hold on, y'all. All right. So the next book is this right here. This is Thermal Physics. Thermal Physics by Morse. So yeah, this book is it's a standard thermodynamics book. It's nice. It goes through everything. You know, everything at a advanced undergrad level. So yeah, like it just straight up just goes over everything. It's a classic thermodynamics book. So next one is The Principles of Chemical Equilibrium by Kenneth Denby. I think that's how you pronounce it. I don't know, but this is a standard text on chemical thermodynamics. So this is literally the standard like rigor of chemical thermodynamics. It's a nice book. This is another one of Leonard K. Nash's books. It's called Elements of Chemical Thermodynamics, and it's another lower level, like lower undergrad level, like just as a first book on chemical thermodynamics. I'm planning on going through this one and this book on statistical thermodynamics by Leonard K. Nash at the same time at some point. This is Thermal Physics right here. This is Thermal Physics by C.J. Atkins. It's a decent book. It's almost at the same level as it's like lower undergrad level. So like another it's one of those books they kind of like ignore the hard theory. Not ignore it, but like they don't go as hard on the hard theory and stuff, and like it's more of a book to help you get a general grasp of the ideas. It's one of those type of books, lower level. Right here, this is a thermal physics book by Schroeder. I'm sure you all know about this one. Just typical undergrad level of thermodynamics undergrad treatment. This is Fundamentals of Classical Thermodynamics by Sontag and Van Wylen. Typical. I'm pretty sure you guys have heard about this book, but it has thermodynamics. It has both engineering thermodynamics and just classical thermodynamic type. I actually think it's more of an engineering thermodynamics type of book, but the topics intertwined. So next book is chemical. This is Introduction to Engineering Chemical Engineering Thermodynamics by Smith and Van Ness and Abbott. It's a really good book from what I've heard. It was recommended to me. This along with the book by Warren and Shapiro was recommended to me by a PhD chemical engineer with like 40 years of experience in the he is a retired chemical engineer with 40 years of experience in the field, PhD. So yeah, this is nice. It goes over a lot of different things. Like, it's a thick book actually. Goes over a lot of different things. A lot of different heavy topics. So yeah. This book right here was a book that was required for my course in thermal physics. It's pretty low level actually. It starts with a table of elements, and then goes into other stuff, and it kind of explains like a lot of these basic formulas, and like it's on the same level as I will say the book by Atkins. Just goes over basic statistical physics and basic things. Talking about macrostates and microstates and stuff. It's pretty it's not like an undergrad treatment, not like advanced undergrad treatment. It's just a pretty basic book. It's nice though. It's nice. So yeah, hold on, guys. Let me put this down real quick. So this next book is Vector Calculus by Baxendall and Liebeck. Classic vector calculus book. It's really well written, proof based, and it's nice. It's a nice book. It goes through pretty much everything that you would see in what Calc 3 is supposed to be type of course. And this is another summer book, Vector Calculus by Marsden and Tromba. Another nice book. I'm pretty sure you guys have probably heard about this one. This next book is Multivariable Calculus by Don Shimamoto, and it's another nice book. It's more computation based than Marsden and Tromba and Heisenberg. Hans and Liebeck. Not whatever. What's his name? Baxendall and Liebeck. So yeah, this is also a nice book. I got it printed and bounded. This is this book in particular is I forgot what you call it. I forgot what you call it, but it's it has a Creative Commons. It has a license where you can print it and distribute it however you want. And yeah, it's a nice book. Really, it's pretty well written. This right here is Elementary Differential Equations by Boyce and DePrima. Classic book. I went through the first couple chapters of it. It has nice practice problems, but the explanation is kind of lagging, which is why I switched to the book by Reese right here. I think it's better in terms of the explanation part, especially for a person that's beginning to learn the topic. All right. This book here is Multivariable Calculus by Ron Larson. It's one of the standard Calc 3 type textbooks, very computation based, but it's good for practice problems. Lots of different practice problems. Let me take these books, put them right here. This right here is Linear Algebra and its Applications by David C. Lay, computation based book. It's about matrices and all that. And it's decent. I need to work through this for my next class on linear algebra, which I'll be taking next semester, a couple weeks. All right, so this book here is a book on this is Classical Mechanics by Barger and Olson. Type Classical Mechanics of Modern Perspective. Haven't looked at this book too much, but it goes over everything like related to like classical mechanics at the undergrad level. The Lagrangian, Hamiltonian formulations, and energy conservation and all that. It's a nice book. Then I have a survey of, you can't really see the title probably, but it's a survey of geometry by Howard Eves. It's also a good book. A lot of good exercises. I got it because I just figured that maybe I don't know why I got this book, but I'm gonna go through it at some point. It's thought that maybe learning more elementary geometry. Well, it's not. It's like geometry at like a higher level, but it might provide insights on different things. So yeah, it's just classical geometry. Let me put these back real quick. So this is Ordinary Differential Equations by Layton. I've heard it's good as the second book on ordinary differential equations. It's decent. It's decently written from what I've seen. This is a book I got from my library's Differential Equations by Simmons. This is the whole title, Differential Equations with Historical Notes, I believe, by Simmons. With applications and historical notes. This is a really good book from what I've heard. I've read through parts of it. This is Problem in General Physics by I.E. Irodov. It kind of goes with the Irodov has like a series. Like, remember this book right here is also written by Irodov, but he has a series of books on like general physics. And this the first volume is the mechanics one from the first volume is the mechanics one from what you can see back here. And it's just a bunch of different problems on general physics, like what we just saw RLC circuit, some different stuff. So yeah, this is Problems in Mechanics by Mishchersky. I don't know if you guys know, but the Russian books are actually pretty problem focused. So like a lot of Russian education was very problem focused. So this book, I've worked through the first few exercises. They're really good for just understanding, physics, like just basic physics problems. Like a lot of these problems vary in difficulty and they vary in topic. Like you have coplanar force system, forces in 3 dimensions, like statics. Then you have kinematics, all this good stuff, all that good stuff, dynamics, just all that good stuff. Like you have a bunch of different types of problems. This is in English engineering units as well. But a lot of the problems aren't even in a lot of problems are solved in a variable form. So it's nice. So let's get to some more stuff. Hold on. This is Mechanics by J.P. Den Hartog. Newtonian Mechanics. This is all this deals with is Newtonian Mechanics. It's a decent book that I want to read through. It's nice, really nice. This is Mechanics by Keith Simon. It's a classical mechanics book. I'll start going through these a little bit faster. This is Problem in Undergraduate Physics, Mechanics. This deals with both Newtonian and classical mechanics, but it's another problem book, like another Russian problem book. This right here is Introduction to the Principles of Mechanics by Walter Hauser. I don't know much about this author, but I do know he wrote another good book called on electromagnetism. This book can be found cheap, but the electromagnetism book is very expensive and because it's out of print. But he goes over everything. This is like a classical mechanics book. You need it formulates like everything. So these books down here. This is Introduction to Linear Algebra and Tensors by Kivas and Goldberg. It's nice. I read through the first chapter. Talks about vector spaces and everything. And you know, it gets into, it's like a proof-based type book, so it gets into everything. So, you know, this is definitely a good book that I'm gonna get through. Like, I'm definitely gonna get through this one. And this is Vectors and Tensors in Engineering and Physics by D.A. Danielson. There's another vector and tensor analysis book that's at a lower level than the ones by like Harry Lass and the one that I showed you by Nathaniel Coburn. It's also a nice book. All right. So this is Linear Algebra by Shiloh. Nice book. Linear Algebra by Hoffman and Kunz. It's another nice book. This is a graduate level book by Hoffman and Kunz. Linear Algebra by Mansfield. Linear Algebra, a Geometric Approach by Mansfield. I actually read some of this book and it's really well written so far. It has nice exercises. Then the last one is Matrices in Linear Algebra by Schneider and Barker. Good books. All right, so now I'm gonna take you guys downstairs to my other books. All right, so hold on. Put these back real quick. Yeah, if y'all interested, this is also, you know, one of my Chinese books. It's a Chinese course, you know, 一年级教材, 汉语教程, so it's just a Chinese course, and this is for apparently it's for undergrads. This is 对外汉语本科系列教材, so it's to, you know, it's for like foreigners trying to learn Chinese, you know, in undergrad. So, you know, it's decent. It's actually pretty easy. But I actually think this is actually like a first grade level book for Chinese students, like actual students, like in China, native speakers. You know, this is a first grade level, you know, fluency. If you possess fluency of a kindergarten, that's still like a lot. You know what I'm saying? Especially when you're speaking a foreign language, like that's really nice. So yeah, let me head downstairs to my other stuff. Give y'all a look. It's not looking horrible, but aside from some useless books on whatchamacallit, on real estate, they're not useless. I just don't plan on reading them. I don't think. This book right here, this is Analytical Dynamics by Whitaker. So, you know, this is actually a classic book, if I remember correctly. Like, it's on analytical dynamics, covers everything. This is Advanced Calculus of Several Variables by C.H. Edwards Jr. I'm pretty proud you guys have probably heard of that book. This is Statistical Mechanics by Donald A. McQuarrie. This is the international edition. You know, Statistical Mechanics. This is actually I think the reprinted version of his old book, Statistical Thermodynamics. And this big ass book right here. This is Gravitation by Kip Thorne and Misner and Wheeler. General Relativity, just like the authority on general relativity. All right. So everything goes. You have exterior calculus, like everything, differential forms, tensors, all that mumbo jumbo. All right. So let me head to my actual library room, which is in here. My mom actually teaches in here because she's a teacher. So, my gosh, I realize how many books I have. So it's like a lot. Now look, there's a whole row of books behind here. All right. So I have equilibriums. I'm literally just gonna let you guys see them. So you can see these right here. You can see the books behind. All right, you see this. You see this is Wangness and electromagnetic fields and a modern, a modern course of statistical physics. Behind here is heat transfer. This is a course of modern analysis by Whitaker and elements of power system analysis by William D. Stevenson. And behind here is partial differential equations by Yost, and methods of molecular quantum mechanics by McWeeny. These two, this is pulse and digital circuits by Millman and Taub, I think is his name, and numerical partial differential equations by Thomas. This is one part in a series, I believe. And behind here is partial differential equations by Duff, statistical mechanics by Davidson, which is a good book, and a heat transfer textbook by Lionheart, which is nice. Right here's a huge, big-ass tome called Radar Handbook by Skolnick. Goes through a lot of different stuff. Honestly, couldn't even tell you. This is Principles of Electromagnetic Compatibility by Kaiser. Goes through a lot of different things about electromagnetics and which devices, how do you. Electromagnetic compatibility is about how you can keep other devices from interfering with other devices, keep the electromagnetic fields and stuff from, the signals from interrupting with other devices. All right, at least I think so. So, yeah, you have that. Then I have Purcell's book on, Purcell Lemoine's book on electricity and magnetism. Got a bad copy. It was fucked up, so, I had to tape that bitch up. Then I got, Elements of Calculus and Analytic Geometry by Thomas and Finney. Right here, I have Mechanics by Landau and Lifshitz. And, it's right here. You guys know this book, Tensor and Vector Analysis by Springer. That's his name. Foundations of Statistical Mechanics by Penrose. Behind is the third volume of the Feynman lectures. I have Inside Interesting Integrals by Nahan, a book on learning tricky methods to solve integrals, and Modern Problems in Classical Electrodynamics by Braw, a good book on the level of Zangwill. Behind is Electromagnetic Fields and Waves by Lorraine and Corson, and Statistical Mechanics and Thermodynamics by Claude Garrett. Right here is Riemannian Geometry by Peter Peterson. And behind is Partial Differential Equations by John. Right here is Maurice's book on organic chemistry. And behind is the book The Geometry of Physics by Frankel. And Problems in Alternating Currents by Leon. Right here is Tensor Analysis for Physicists, which is actually a really, really hard book to get through. It's a lot of tough notation, a lot, And next to it is Irresistible Integrals by Moll and Boros, another book about integrals and stuff. Oh man, I forgot to mention that I have another book upstairs on physical chemistry by Levine. All right, it's by Levine. I forgot to show you guys that book, but right here is Physical Chemistry by Ball, which is decent. And behind these books is Mathematics of Physics and Modern Engineering by Sokolnikov. It's a good book. Goes through like pretty much all of undergraduate mathematics. You know, infinite series, like literally everything, Laplace transform, all of that. Then you have Kinematics and Dynamics of Planar Machinery, which is a nice book. It's by Burton Paul. It gets intensive into like the mechanics of machine parts. Yeah. Right here I have Zangwill, Modern Electrodynamics. Good book. You guys probably know about this one. Applied Mechanics Dynamics by Howland and Hudson, which is also a good book. And I have Problems in Thermodynamics and Statistical Physics by P.T. Landsberg. Right now behind here is Integral Evaluations Using the Gamma and Beta Functions and Elliptical Integrals in Engineering by Mikan. Good book on, you know, learning different integration methods. Fundamentals of Circuit Theory by Balabanian, which is another good book. Transport Phenomena, BSL's book on transport phenomena, and Fundamentals of Statistical and Thermal Physics by Reef. Or Rafe, or however you say it. Oh man, getting out of breath. Oh shit, it's another stack. So look, right here. This is Applied Multivariate and Statistical Analysis by Johnson. Advanced Calculus and Introduction to Analysis by Folks. Analysis of Numerical Methods by Isaacson and Keller. Boundary, Series, and Integrals. Boundary. Fourier Series and Integrals of Boundary Value Problems by Hanna. So these are some other good books. Right here, more stacks. Introduction to Analytical Dynamics by Woodhouse. Difference Equations by Kelly. Prigogine and DeFay, Chemical Thermodynamics. I don't know if that's how you pronounce his name. I'm sorry. But, or her name. I actually don't know whether this is a male or female, but I do know that this is a Nobel Prize winning chemist. I think he won in 1970. So this is his book on chemical thermodynamics. This is Thermodynamics and Statistical Thermodynamics by Aston and Fritz. This is Principles of Dynamics by Greenwood. Yeah, D.A. Donald T. Greenwood, right. This is Solid State Physics by Blakemore. Got this book from my library, my school library. Behind these two is Introduction to Statistical Mechanics and Thermodynamics by Stowe. Fluid Mechanics by Gross and Gerhardt. Engineering Circuit Analysis by Haight. 2000 Solved. It's one of Strom's problems in the electromagnetics book. This is the second volume of the Feynman lectures on electromagnetics. This is Engineering Electromagnetics by Haight back here. Engineering Electromagnetics by Haight. Right here, this stack of books. This is Fundamentals of Complex Analysis for Mathematics, Science, and Engineering by Saff and Snyder. Under here is Applied Complex Variables by Detman. Under here is Thermodynamics of Irreversible Processes by the same person that wrote this book right here. Prigogine. I think that's how you pronounce his name. So sorry. Mechanical Vibrations by Den Hartog. He also wrote one of the mechanics books I have upstairs. This is Advanced Calculus by Loomis and Sternberg. This is actually a famous book. This is actually the book that MIT honors students go through, I think, on Advanced Calculus. I forget what grade level, but it's hard. It's pretty hard. This right here is Physical Chemistry by Nagel. And behind these books are this blue book is Numerical Partial Differential Equations by Hall and Porshing. Next to this is Classical Electrodynamics by Jackson. Nothing more needs to be said about that. I have Physical Chemistry by Castellan. Chemical Thermodynamics by Peter Rock. Classical Dynamics of Particle and Systems by Marion and Thornton. Heat Thermodynamics and Statistical Physics by Franzo H. Crawford. All right, you get another stack of books right here. These two right here are prints of a book that I got on integration. It's a treatise on integral calculus with applications, examples, and problems, volumes 1 and 2 by Joseph Edwards. So this goes like deep into integration, like really deep. Like both of these books are both like 1,000 pages long, so you know everything you want to know about integration is in here. All right, so these books right here. This is Analysis and Design of Analog Integrated Circuits by Graham Meyer. I don't know, I should have got the other edition because this one focuses too much on I forgot what it was, but there's something that's like that's found in the later editions that these early editions don't focus on. So I missed out on that, but I can always learn online. This is General Topology by Willard, which is a good book. Fundamentals of Heat and Mass Transfer by Encropera and DeWitt, which is a good book on transport phenomena. I have Mathematical Methods for Physics and Engineering by Riley, RHB, Riley, Hobson, and Bentz. And behind these books is a foundational book on chemistry, a college chemistry book, CRC handbook on mathematical functions of mathematical science. It has everything on like applied mathematics. Behind you is Chemical Engineering, Kinetics by Smith. And I have Partial Differential Equations by Levine. Right here, this is a big book right here. And I have Theoretical Mechanics of Particles and Continua by let me see this author's name, by Woleka and Fetter. That's what this is. And I have Quantitative Chemical Analysis by Harris, along with this book right here, which is like the Solutions Guide to. Because when I ordered the book, I meant to order the textbook, but they gave me this because I must have misread. They gave me the solution manual, so I had to order that particular edition of the book, or I decided to just because. So yeah, that's these two stacks right here. These are more Chinese books right here, but also some other stuff. So I'm gonna just go with you guys through the science books and stuff. So this is Continuum Mechanics by Chung. This is Integral Equations by Trichomi. This is Durrell and Robson. Durrell and Robson's Advanced Trigonometry. This is Terrell Hill, Statistical Mechanics Principles and Selected Applications. This is Junji Fancy. This is Matrix Analysis. Right, this is Matrix Analysis by Horn and Johnson. This is Thermodynamics and Statistical Physics by Kelly. Problems and Solutions, Thermodynamics and Statistical Mechanics by I think his last name is Kim. Yeah, Young Kuo Lim. Yeah. That's a yeah, this is a book on problems and statistical and thermodynamics. Like statistical mechanics and thermodynamics, a problem book right here. So right here, these are some chapter books that I don't even read. These aren't even mine. This is Classical Electromagnetism by Gerald Franklin. This is Fields and Waves in Modern Radio by Ramo and Winery. These are some other books on Chinese. I read through some of this. These are HSK books. HSK is the Hanyu Shuifen Kaoshi, which is pretty much a standardized test on Chinese ability. It has 6 levels. They actually just reinstituted more levels. But anyway, this is Differential Geometry by Erwin Kreisig. It's actually kind of outdated from what I've heard, but it's a place to start. I don't mind it being outdated. I can always fill in the holes where I need to. Now, there's a lot of more books back here. This is a Russian course book that I bought by Brown. You know, it goes through some basic Russian things. I haven't read it, haven't read through it. I read the part of it, but like not all of it. I've been slacking on my Russian studies lately. Back here, this is partial differential equations of mathematical physics and integral equations by Gunther and Lee. Hopefully I don't have to move all these books back here. But this is, back here you have Continuum Mechanics by Chadwick, which is a pretty concise book on continuum mechanics. Heat and Thermodynamics by Zemansky. Quantum Mechanics by Merzbacher. Mathematical Methods in Physics and Engineering by Detman. Mathematical Methods by Potter and Goldberg. Tensors, Differential Forms and Variational Principles by let me see if I can see, by Lovelock and Rund. You also have Theory and Application of Infinite Series by Conrad Knopp. I think you pronounce this guy's name Use, but it's, theoretical physics. His Dover book. And I have another book by Mieszewski on collection of problems in theoretical physics. Rayton Milford's book on Foundations of Electromagnetic Theory. This book by Hauser, Introduction to the Principles of Electromagnetism. Another book on mechanics problems by Karelitz, and Ormondroyd, Problems in Mechanics. This book that I got from my library on condensed matter physics. Lanczos, The Variation Principles of Mechanics. Gelfand and Fomin, Calculus of Variations. Albert Messiah's big book on both volumes on quantum mechanics. Vector Analysis and Cartesian Tensors by Born. Tensor Analysis on Manifolds by Bishop and Goldberg. Mathematical Foundations of Statistical Mechanics by Kinchin, I believe that's pronounced this person's name. Borisenko and Toropov, Vector and Tensor Analysis with Application. Singe and Schild, Tensor Calculus. Many more books. Advanced Inorganic Chemistry by Wilkinson, Cotton and Wilkinson. This is actually a famous book right here. Inorganic Chemistry by Miesler and Tar. Fourier Series by Tolstov. An introduction. This Fourier Series by Tolstov. An introduction to I don't even know how you pronounce. I don't even know. I always say Lebesgue integration and Fourier series. I know what this is, but like I've heard it before, but I never knew how to say it because I never heard anyone say it. This is Statistical Mechanics by Carson Huang. Physical Chemistry, a Molecular Approach by McQuarrie, famous book right here. Physical Chemistry by Moore. I have Ordinary Differential Equations by Pollard and Tenenbaum. My own book on a table of integrals, series, and products by Grashstein and Reisig. Don't know how you say their names. Sorry. Classical Electricity and Magnetism by Panofsky and Phillips. Volume 2 of the Mathematics of Physics and Chemistry by Marginal and Murphy. Special Functions and Their Applications by Lebedev. Guggenheimer's book on differential geometry. Lanier's book on statistical physics. This book on infinite series by Hirschman. Rainville's book on infinite series. Series and Salinger, Thermodynamics, Kinetic Theory, and Statistical Thermodynamics. Transport Phenomena and Kinetic Theory by Serzagani and Gabetta. And this book is actually pretty, this is a very high level book right here. Very high level. Electromagnetic Fields and Waves. This is the book by Rojansky. Franz Straubel's book on Statistical Mechanics. Quantum Mechanics by Straubel. The Calculus of Variations by Weinstock. The Fractional Calculus by Oldham and Spanier. That's a tough book. You have to go through a lot of some functional analysis before you can even approach that. Advanced Calculus by Taylor and Mann. Problems and probability theory, mathematical statistics, and theory of random functions by Sveshnikov, something like that. Classical mechanics by Goldstein right here. Molecular quantum mechanics by Atkins. Royden's book on real analysis. The Handbook of Integration by Zwillinger. Morin's book on classical mechanics. Gregory's book on classical mechanics. Haley's book on quantum mechanics. Electromagnetic waves. Propagation, radiation, and scattering by Ishimaru. Problems in quantum mechanics by Squires. Heat transfer by White. This is real and complex analysis by Rudin. This is Rudin books on real and complex analysis. This is the Chinese version. Well, it's not written in Chinese, but it's just the title is in Chinese because I got it from a person in China. Well, not a person in China, but a Chinese student. A Chinese American student, or a foreign student from China studying here. Where I got it from off eBay. So yeah, this is real and complex analysis by Rudin. This is Signals and Systems, Continuous and Discrete by Zeimer, Tranter, and Fannin. This is Thermal Radiation, Heat Transfer. This book is by Seigel and Howell. Next row, Introduction to Combustion, Concepts and Applications by Turns. This is Complex Analysis by Alfors, Loris Alfors. This is a famous complex analysis book. This is Burden and Fair's book on numerical analysis. Powers' book on boundary value problems. Nagel and Saf's book on fundamentals of differential equations. Rapid prototyping of digital systems by Humble and Furman. Abstract algebra by Judson. Thermodynamics and statistical mechanics by Keith Stowe. Callister's book on material science and engineering. Machinery's handbook. This is a nice book that I was recommended to get. Differential equations and their applications down here. This yellow book by Braun. Quantum chemistry by McQuarrie. Leibov's book on introductory quantum mechanics. Some books that I didn't mean to get on dynamics and on engineering, mechanics, dynamics. Thought they were real complete books, but they're just workbooks. Yeah, tough. Churchill's and Brown's books on Fourier series. Oh man. Discrete mathematics and its applications by Rosen right here. Introduction to partial differential equations from Fourier series to boundary value problems by Broman. Advanced calculus right here by Witter. Advanced quantum mechanics by J.A. Sakurai. This is another foreign book. This is which is quantum mechanics. This is advanced quantum mechanics. Trigonometrical series by Anthony and Zygmunt. Solid state electronic devices by Streetman. Let me put these back here real quick. I have even more right here. This is another edition of Numerical Analysis by Burden and Fair. Didn't mean to get that. This is Chemical Applications of Group Theory by Cotton. Same guy that wrote that inorganic chemistry book. This is Eris's book on vector tensors and the basics of fluid mechanics. This is Advanced Mathematical Analysis by Richard Beals. This is Rosen's book on fundamental principles of polymeric materials. This is Serge Lang's book on complex analysis. This is Burdett and Wangbo and Albright's book on orbital interactions in chemistry. This book down here is Mathematical Statistical Mechanics by C.J. Thompson. This is Morris Manos' book on digital design. This is Sadiko's book on fundamentals of electric circuits, another circuit analysis book. This is Thermodynamics by Wark and Richards, which is like another engineering thermodynamics book. Oh. Now we're getting to the last part of my books. This is Thermal Physics, Introduction to Thermal Physics. To Thermal Sciences by Schmidt, Henderson, and Wedgmuth. It's like a fluid mechanics and like it's like a it's another transport like mass transport type book. You know, this is thermodynamics by Asterita, chemical. No, it's thermodynamics an advanced textbook for chemical engineers by Asterita. This is classical mechanics by Kibble and Berkshire. This is the classical electromagnetic field by Aegis, I believe that's how you pronounce his name. This is fluid mechanics by White. This is one of the older, right here. This is one of the older editions on Arfkin's book for mathematical methods for physicists. This is one of Boylested's books on like semiconductor about devices, you know, electronic devices and circuit theory, semiconductors and stuff. This book right here is an elementary treatise on Fourier series and spherical, cylindrical, and ellipsoidal harmonics with applications of problems in mathematical physics. Long ass title. A lot of stuff in here. Lots of it. Try to put this back. This is Classical Electrodynamics by Grainer. Fundamentals of Mass, Heat, and Momentum Transfer by Wiley, Wicks, Wilson, and Rohrer. This is Fundamentals of Fluid Mechanics by Munson, Young, and Okisi. This is Summerfield's book on electrodynamics. This is Rice's book on mathematical statistics and data analysis. This is a book on potential theory called Foundations of Potential Theory by Kellogg. This is Balanis' book on antenna theory right here. This beige one right here. This is Balanis' book on antenna theory. This is Linear Systems and Signals by Lathy. This is Principles of Electrodynamics by Schwartz. Electricity and Magnetism by Cottingham. Foundations of Electrodynamics by Moon and Spencer. An Introduction to Sequences, Series, and Improper Integrals by Stanaidis, I believe that's pronounced his name. Griffith's book on electrodynamics, which you guys probably know. Optimal Control Theory by Young. Lorraine and Corson's book on electromagnetism. Krauss and Carver's book on electromagnetics. Slater and Frank's book on electromagnetism. Paley and Weissel's book on abstract algebra right here. First course in abstract algebra. This book is on the mechanics of solids by let me see the title. Introduction to the Mechanics of Solids by Robert Archer, Nathan Cook, Stephen H. Crandall, Norman C. Dahl, Frank A. McClintock, Ernest Rabinowitz, and George S. Reichenbach. This is Partial Differential Equations for Scientists and Engineers by Farlow. Prominix book on electromagnetism. Electromagnetics, Classical and Modern Theory and Applications by Seeley and Polaricus. And this is Balanis' book on Advanced Engineering Electromagnetics. These are all the books that I have so far. I have more on the way, like the book Multivariable Mathematics by Ted Schifrin, some other books on electromagnetics. But yeah, that's it so far. All right. Thanks for watching.